Continuing our lesson on factoring expressions, if we look at workbook page 53, number 1, we have 21a plus 9, and they want us to factor that. So first of all, they're kind of giving things away a little bit here. They're telling us that the greatest common factor is 3. And so then they're just kind of a thought process here. 3 times something to get 21a. Well, 3 times 7 is 21, and then we would need an a after that. 3 times what to get 9? That would be 3 times 3. And so our factored expression, we factor out the greatest common factor, which is the 3, and then we would be left with 7a plus 3. Okay, again, like we talked about before, if you guys want to think about after factoring out the 3, think about, 3 times what to get 21a would be 7a, 3 times what to get 9, and that would be 3. So this would be our factored expression for number 1. So number 2 is similar idea. This one, notice our first term, we have a negative number in front of it, so we want to factor a negative out this time probably. With 18 and 27, those both have a 9 in common, so we're going to factor out a negative 9. Negative 9 times what to get 18y? Well, negative 9 times 2 would be negative 18, and then we need a y on that. If you want to, on this one, you can add the opposite. We need to think about that as a negative 27. Negative 9 times 3 would be negative 27. So our factored expression would be negative 9 times the quantity 2y plus 3. Again, technically, you could factor out like negative 3 or something like that, or 3 or 9, but factoring out negative 9 is probably going to be the most beneficial as you go along in math. So if we look at number 3, they took the training wheels off here, so we get to kind of do the work here on our own a little bit more. So with this one, we're going to look at the numbers first and see what those have in common. So the highest number that the 8 and 36 both have in common would be 4. One thing you can do to test that, if you're not sure, if you're just kind of guessing a number, you could divide both of them by 4, and then you could make sure, 2 and 9 is what we would have left at that point. Think about if those have anything in common besides just dividing by 1, and they don't. So that tells us that we do have the biggest possible factor, our greatest common factor. You could also do factor trees we've talked about before, and then look for, basically you would have 2 factors of 2 in common, just to mention that to you quickly here. Okay, break them down however you want to break those down, and then we look for factors in common. So we got a 2 in common, we've got another 2 in common, and that's all. And so we multiply 2 times 2 is 4. Okay, so there's different ways that you can come up with that greatest common factor. So 4 is our greatest common factor. So if we factor out a 4, we need to think now 4 times what to get 8x. 4 times 2 is 8, and then we need the x after it, so we need a 2x to start out. Then on our second term, we need 4 times something to get 36. That would be 4 times 9 to get 36. So 4 times the quantity 2x plus 9 would be our answer for number 3. We look at number 4. Same idea. We're going to look for a greatest common factor. So greatest common factor of these actually happens to be 4 once again. So now we're thinking 4 times something to get 28y. 4 times 7 is 28, and then we need the y after that. And then minus. So that would be 8. 4 times 8 is 32. If you wanted to at the beginning, we've been talking a lot about adding the opposite. So if anybody added the opposite first, and if you've got your answer listed as that. Okay, either way, either of these answers would be perfectly acceptable. So number 6, Josh is trying to factor the expression. He writes -4 times the quantity 5a plus 2 plus 3b. What error did Josh likely make? So we can think about what he's got here, think about if it works or not. So -4 times 5a would be -20a. So that part's okay. We've got -4 times 2 is -8. And if we add the opposite up here, that looks to be okay. And then we've got -4 times 3b would be -12b. So that part does not match up. So probably was just a mistake about, since we factored out a negative, he just made a mistake there. Okay. So the book's explanation, they just said that Josh kept the third term positive, which would become negative when multiplied by a negative factor. In other words, we factored out a -4, so, you know, something to that effect. Again, you could just say something about it should have been -3b, so that when you do -4 times -3b, you get +12b. All right, and then part B, they want us to factor it correctly. So the first two were correct. It's just the last one. We should have had a -3b instead of a +3b. Number 7, they're asking what are the possible dimensions of the rectangular area at the right. When they talk about dimensions of a rectangle, that means length and width. So we're trying to figure out what our length and width could have been. We know the area of a rectangle is length times width. So if our area is 27x minus 9, what we need to do is we need to factor that. If we can factor something out, get it to be something times something else, then we can say one of those factors is my length and the other factor is my width. So with our numbers 27 and 9, greatest common factor would be 9. So if we can go ahead and factor a 9 out, and then we can think about what we would have left. So factoring that out, 9 times 3 is 27. So that would be 3x. And then minus, or if you added the opposite here, and that would be a 1 there. So plus -1, or you could have -1 would be the same thing. Okay, now the question actually is what are the dimensions? So at that point we would actually need to say that maybe our width is 9 and our length is 3x minus 1 or 3x plus -1. Okay, just by factoring it, we haven't really answered the question about what the dimensions are. So look at number 8. They have an expression, and first they're asking what is the greatest common factor. So we're just looking at the numbers, so 14, 28, and 21. So with those numbers, our greatest common factor would be 7. That's it for part A. Part B, they want us to factor it. So factoring, we would have a 7 out in front. And then we need to think about 7 times what to get 14x. And that would be 2x. 7 times what to get 28y. That would be 4y. And then 7 times what to get 21. And that would be 3. So that would be our factored expression. So number 10, a landscaper is adding a stone path around a rectangular patio. The width of the patio is represented by x. The length is 6 feet more than twice the width as shown. Write two expressions to represent the perimeter of the patio. Okay, so the picture they gave us, they actually didn't have to do that. That was nice of them. They could have just told us the information and we could have figured out the x and the 2x plus 6. For a perimeter, it goes all the way around. So we've talked about before, for a perimeter we have 2 lengths and 2 widths. So the length, if the length is 2x plus 6, we're going to have 2 of those. And we're going to have 2 widths. The width is x. And what we can do here is we can actually distribute. That could actually be one of our expressions right there. Okay? And then we can distribute this. So 2 times 2x plus 2 times 6 plus 2 times x. 2 times 2x would be 4x. 2 times 6 is 12. 2 times x is 2x. That could be another expression, technically. And then what you can do here, you can actually combine those like terms together, and that would be 6x plus 12. So 6x plus 12 is probably what I would choose as maybe the best answer for an expression for the perimeter. Another thing you could do, what the book's doing, is once they got to that point, they factored a 6 out. And they said 6 times the quantity x plus 2. That would be another option that you could give for the perimeter of the patio. Another option you have would be, if you just know perimeters going all the way around, you could say I've got an x, I've got a 2x plus 6, I've got an x, I've got a 2x plus 6. You could have all of those and then just combine your like terms together, and you would actually get to 6x plus 12 that way also. All right, so it does not require that you do the distributing and stuff like I did, although that's what they're hoping that we did to work that problem out, I guess. Number 11, they're asking which of the following shows a way to factor this expression. Select all that apply. Usually means at least 2 of them are going to work. Not always, but usually. So what you can do here, if you want, in these parentheses, anytime they're subtracting, if you want to add the opposites there, you can. And then we can just distribute. So negative 6 times x plus negative 6 times negative 3. That would be negative 6x plus 18, so that works. The next one, we can put a 1 in front of the x if you want. So 6 times negative 1x plus 6 times negative 3 would be negative 6x plus negative 18 or minus 18. That does not work. The third one is going to also be negative 6x plus negative 18, so that does not work. The next one would be negative 6x plus 18, so that works. And the last one would be 6x plus negative 18 or 6x minus 18, so that does not work. So there are the 2 answers that work for number 11. And if we look at number 12, they want us to write 2 expressions that show the product of 2 factors and are equivalent to negative 15y minus 40. So if you want to add the opposite there first, you can. Since our first coefficient is negative, I'm going to probably go ahead and factor out a negative number. If we look at our numbers, 15 and 40, they have a 5 in common, so we could factor out a negative 5 and then think about what that would leave us with. So negative 5 times what to get 15y? So that would be 3y plus negative 5 times what to get negative 40, and that would be 8. So this would be one answer. That, to me, is probably our best choice. To get another factor, what we could do is it has to be a product of two factors, so we have to factor something out. So another option would be to factor out a 5, and then it would look like that. Technically, you could factor out a -1. Factoring out a 1 is kind of cheating because you're not really changing anything. So please don't choose that as one of your answers. So this gives you an idea of how to factor expressions.